Hello friends, in this video we are going to study about the frequency selective wave analyzer. It is a type of wave analyzer. So in this video we will study its working, block diagram and applications. So let us start with our topic. Before starting with the frequency selective wave analyzer, let us understand that what is a wave analyzer. A wave analyzer is an instrument which is used to measure the amplitude of the signal at a particular frequency. So if we say that a wave analyzer, it is an analysis instrument which is used for the analysis of a signal. Now if we know that a signal, it is a waveform, okay, and a periodic waveform of if we say a complex waveform, it is a sum of the fundamental components and the harmonic components. So whenever we are doing the analysis over a complex periodic waveform, then the characteristics of both the fundamental and the harmonic components will be measured. Now, if we want to measure the characteristics over a particular single frequency, then we use the wave analyzers. So, wave analyzers, they are the signal analysis instruments which are designed to measure the relative amplitudes of single frequency components in a complex waveform. So in that waveform we are having different frequency component. So at a particular frequency component, it is going to measure the amplitude. Okay, so we can say that basically the wave analyzer, it is a voltmeter which is measuring the value of the voltage at a particular frequency, or we can say that a voltmeter which is tuned to a particular frequency. That is why wave analyzer, it is also called the frequency selective voltmeter. So this frequency selective voltmeter, it is tuned to the frequency of one signal while rejecting all other signal components. So all the other components like the harmonic components or any other components present in the signal, they will be removed, and only the frequency, that particular frequency, at that frequency the amplitude will be measured by this voltmeter. Now the frequency at which we want to do the measurement, this desired frequency is selected by a frequency calibrated dial which is present on the front panel of the instrument. Okay, so through that frequency dial we are measuring, we are selecting the desired frequency, and at that frequency the amplitude will be shown either by a cathode ray oscilloscope or by a voltmeter. So the desired frequency is selected by the frequency calibrated dial, and this dial is going to indicate us the maximum amplitude which is given by the CRO or the voltmeter. So this is how the basic wave analyzer work. Now the wave analyzer, they are of two types. One is the frequency selective wave analyzer and second is the heterodyne wave analyzer. So here we are studying about the frequency selective wave analyzer. These two type of wave analyzers are categorized on depending upon the frequency range used by them. So we are having the two types: frequency selective wave analyzer, which is working over the audio frequency range. So let us study about this wave analyzer. So this analyzer is going to operate over the audio frequency range, that is from the 20 Hz to the 20 kilohertz. Now, as I said that all the wave analyzer, they are going to measure the amplitude at a particular frequency. So how this particular frequency or single frequency is to be selected, that is in the frequency selective wave analyzer, we are having a very narrow band pass filter. Okay, and this band pass filter is going to allow only the particular frequencies band from it, and from this band pass filter, it will be tuned to a particular frequency only. Okay, so at that frequency component we are measuring the amplitude. So what the basic circuit of this frequency selective wave analyzer consists of, it will consist of a very low band pass filter. Okay, low pass filter will be there, and this filter is tuned to a particular frequency which is within this frequency band range, that is 20 Hz to 20 kilohertz. So this is going to consist of a very narrow band pass filter which is tuned to a particular frequency range. So now let's see the block diagram, so that with the help of that block diagram we can see the working of the frequency selective wave analyzer. So this is the block diagram of the frequency selective wave analyzer. You can see the various blocks in it. We are having the input attenuator, then driver amplifier, after that a resistance, then filter amplifier, resistance, capacitance are shown here, then again the filter amplifier. This whole part consisting of the RNC and the filter amplifier, it is a complete high Q filter. Okay, after that we are having the meter range attenuator, then output amplifier, then meter amplifier and detector, This is the dial output meter. So after this meter range attenuator, we have output amplifier, meter amplifier and detector, then dial output meter where we are getting the output which is indicated over this display unit. Okay, this is an indicating type of device here. Then here we are having the output buffer, and this is the output for the auxiliary output for the secondary devices. So this is the complete block diagram of the frequency selective wave analyzer. Let us study the working of this wave analyzer with respect to this block diagram. So first you can see that the input signal, which is a complex waveform, it is given to the input attenuator. So the complex signal or the complex wave which we want to analyze, it is first passed through the input attenuator. The working of this input attenuator or function is to that it is served as a range multiplier. Okay, and it allows a large range of signal amplitudes to be analyzed. So this attenuator, it is going to permit a large value of the signal amplitudes to be analyzed by the instrument without loading the amplifier. You can see that after the input attenuator we are having the driver amplifier. So this attenuator, it reduces the loading over this amplifier by acting as a range multiplier, so that a number of signal amplitude range that can be analyzed by the instrument. So first this input signal is given to the input attenuator, after that it is given to the driver amplifier. Now this amplifier, it is going to amplify the selected frequency component. Here after passing through the attenuator, we are having the complex waveform. Okay, so that complex waveform is further amplified. Now after amplification, this amplifier is going to provide the attenuated input signal to a high Q filter. You can see that this complete block is the high Q filter. So the output of this driver amplifier, which is an attenuated and amplified input signal, it is given to the high Q filter. So this high Q filter, it acts as a low pass filter, allowing only a narrow band of frequencies to pass through it and rejecting all other frequencies. So only that particular frequency which we want to analyze or which we want to measure will be passed through the filter, and all the other frequency components, they will be rejected or removed from the signal. So you can see that this filter, it is going to pass only the frequency which is selected, and all the other frequencies, they will be rejected or removed. Now the magnitude of this frequency which is selected, it is indicated by this meter range attenuator. Okay, and this filter section, it identifies the frequency of the component. Okay, because here in that input signal we are having the various components, so only that frequency component which we want to measure, that will be selected by this high Q filter. So the magnitude of the selected frequency will be indicated by the meter, and the filter section, it is going to identify that frequency of the component. Now this high Q filter or the low pass filter, it consists of the RC resonant circuit. You can see in the block diagram that in this high Q filter we are having two filter amplifiers, two resistances and two capacitors. So this complete circuit, it is a RC resonant circuit, cascaded RC resonant circuit. You can see that we are having two circuits here. Okay, two RC circuits are there which are cascaded in series with each other. So this filter circuit consists of cascaded RC resonance circuit and the filters and the amplifiers. Now in the RC resonance circuit, we are having the resistance and the capacitor. So resistances are used for the frequency control, and capacitors, they are used for the frequency multiplication. So in this way, this complete filter circuit, it is identifying the frequency component of the signal. So for frequency control, the resistances, they are varied, and for the capacitances, they are varied for frequency multiplication. Now the capacitors which are used in this filter circuit, they are the they are the polystyrene type of capacitors. So for selecting the frequency range, we are using here the capacitors, which are generally the polystyrene type capacitors, and the resistances are the precision potentiometers. So capacitors, they are used for the changing the range and the frequency within the selected passband, whereas the resistances, they are used for varying the frequency control. So in this high Q filter, which is consisting of the RC resonance circuit, the capacitors, they are going to select the frequency range, that out of that audio frequency range 20 hertz to 20 kilohertz, which frequency band it has to use. Okay, so it has to utilize. So that frequency band or frequency range will be selected by the capacitor, whereas in that frequency range, whatever frequency has to be selected, that will be done by the potentiometer. So potentiometer, it is used to change the frequency within the selected passband, and capacitor is used for changing the range of the frequency. So in this way, the complete high Q filter, it is identifying the frequency component of the signal, and the magnitude of that frequency component will be displayed on the meter, indicated by the meter. Now, as this here in this high Q filter, the selection of the frequency component is done. That is why this wave analyzer is called the frequency selective wave analyzer, because here we can select the frequency range also and the frequency also. Okay, so this is a type of frequency selective voltmeter, because here the voltmeter, we are saying that wave analyzer, they are a type of DC voltmeter. So we can say that frequency selective wave analyzer is a frequency selective voltmeter, which is indicating the amplitude of the signal at a particular frequency. Okay. So the entire audio frequency range, 20 Hz to 20 kilohertz, it can be covered in the decade steps, means steps of 100. It can be covered by switching the capacitors. By changing the value of the capacitors, we can change the frequency range within this audio frequency range. Okay, we can select any frequency band within this range. Now here in the block diagram, you can see that after coming out of this final amplifier stage, this is the final amplifier in this Q filter. This output, it is applied to the meter circuit. Now in this meter circuit, we are having the meter range attenuator, then output amplifier, then meter amplifier and detector. So this is the meter circuit complete. So the frequency, the magnitude of that frequency will be indicated over this dial output meter. You can see that this dial output meter, it is having the ranges in volts also and in dBs also. Okay, so the both the magnitude will be displayed in the voltage and the dBs range. Okay, now this output is also applied to an untuned output buffer. So the use of this buffer is to drive the output devices like recorders or counters. If any secondary devices are connected to this frequency selective wave analyzer, so this output buffer, it will act as a driver for those secondary devices. So this buffer amplifier is used to drive the output devices like recorders or electronic counters. Okay. Now you can see that on the meter we are having the volt range also and the dB range also. Okay, and this meter, it is driven by a meter amplifier and the detector, which is an rectifier type of detector. So this detector is going to detect the magnitude and display it over this indicating meter, which is having the ranges. Different ranges are there, voltage range is also there and decibel ranges also there. Now The wave analyzers, it is expected that the wave analyzer, they should have very low input distortion. Means they are going to input very low, they are going to add very low distortion in the signal. Okay, the signal should not be disturbed or corrupted due to the internal circuits of the wave analyzer. So it is expected that wave analyzers, they must have extremely low input distortion. And this input distortion, it should be so low that it should not be detected by the wave analyzer itself. Okay. Also, the bandwidth of this instrument is very narrow, typically 1% of the selective band. So because the frequency selective wave analyzer, they are operating over the audible frequency range 20 Hz to 20 kilohertz. So in this frequency range, they can select any frequency band, and the selective band, its bandwidth will be 1% of the selective band. Okay. So its bandwidth is very narrow because of the low pass filter which we are using. This low pass filter is a very narrow band pass filter. Okay. So it is going to give a very narrow bandwidth to the instrument. Now if we see the characteristics of the instrument, so if we see the the attenuation characteristics of the instrument, it will be like, here we are having the, now if we see these attenuation characteristics, the initial attenuation rate, it is approximately 600 dB per octave. So this is the initial attenuation rate. Now here the attenuation at 1.5 of the frequency, you can see that the attenuation is approximately 75 dB. Okay, so the attenuation at 1/2 and twice the selected frequency is approximately 75 dB. Okay, now you can see that the attenuation is increasing as the frequency is increasing, and after the attenuation has reached to 0 dBs, after this center frequency, the attenuation, it again starts increasing. Okay, here it is increasing and here it is decreasing. So in this way, the attenuation characteristics of the wave analyzer, they changes. Okay. So here we have seen studied about the frequency selective wave analyzer. We studied that this wave analyzer is used for the audio frequency range. Okay, and then we studied its block diagram along with its working, that how the different blocks, their functions we studied, and how the frequency selected wave analyzer, it is giving us the output, or which is the amplitude of the signal at a particular frequency, which is selected by the high Q filter, the low band pass filter present in it. Okay. So I hope that this topic, frequency selective wave analyzer, it is now clear to you. Thank you.